Today we're going to look at a graph of a rational function that has a hole in it. Our example being f of x is equal to x squared plus x minus 6 over x squared minus x minus 2. So if we want to find the domain, we'll factor this denominator, x minus 2 times x plus 1. So the domain is all real numbers except for 2 and negative 1. Let's factor the numerator to see that we do actually have a hole. So if you factor this numerator, it's x minus 2 times x plus 3. And because we have this common factor of x minus 2, it implies that we have a hole in the graph. And that hole will be where x equals 2. If we want to find out the exact point of this hole is going to be graphed as an open circle on our graph. So what we can do is we can just cancel out these x minus 2's, because what we're essentially graphing is the function x plus 3 over x plus 1, except where x equals 2 and y equals, if you plug in 2 in for x, you get 5 over 3. So at the point 2, 5/3, you're going to have an open circle in this graph. Next thing we're going to do is find the vertical asymptote. Setting the denominator equal to 0, well, what remains is x plus 3 over x plus 1. So our vertical asymptote is x is equal to negative 1. Horizontal asymptote, because the degrees are equal, we divide the leading coefficients. So y equals positive 1 is our horizontal asymptote. X-intercept, what we're going to do is set the numerator equal to 0. And the numerator equal to 0 means x equals negative 3. So negative 3, 0 is our x-intercept, and our only one. And the y-intercept is when you let x equal 0, you're actually going to get 3 over 1, which is 3, so 0, 3 will be the y-intercept. And the only thing left to do is find additional points. So let's sketch what we have right now. Vertical asymptote of x equals negative 1 with a dotted line and labeled. The horizontal asymptote of y equals positive 1, dotted and labeled. Our x-intercept is negative 3, 0. Our y-intercept is 0, 3. So all we need is a couple of additional points. It looks like this graph is going to go down into the southwest and the northeast quadrant. But let's get some values. Let's get a value where x equals negative 2. Let's see, we already have x equals 1 and x equals 0. Let's get x equals positive 1. And that's probably it. We could get another value where x equals negative 4 just to see what's happening there. So we'll set up our xy table. Let's go back to negative 4. We already know negative 3. Negative 2, we already know negative 1 is not in the domain. So we need a value at x equals 1. And, oh, what the heck, let's just do x equals 3. Plugging those 4 values into x plus 3 over x plus 1, it's a little bit easier to calculate these values of this remaining function when you cancel out the x minus 2's. So if you plug in x equals -4, you're going to get 1/3. -1 over -3. When you plug in x equals -2, you're going to get -1. When you plug in x equals 1, you're going to get y equals 2, or 4 over 2. And if you plug in x equals 3, you're going to get 6 over 4, which is 1.5. So we have a couple of additional points that we can put in our graph. -1, 2, 3, 4, 1/3. -2, -1 is about there, and that's the only thing we have on in the southwest quadrant. So we can sketch that part of our graph. Over here on the right hand side we get 1, 2, so there's a point on our graph, and 3, 1.5 is about right there. And then the only thing we haven't plotted is our hole. Our hole is at x equals 2 and y equals 5/3, which is 1 2/3. So you go over to x equals 2, go up to 1 2/3. It's about right there, and you put an open circle. That is the hole. And when you graph this function, you're going to come down and don't go through the hole. Just graph around it like that. And there you go. There's your graph of a rational function with the hole at 2, 5/3. The next thing we're going to do is look at a different type of asymptote. There's a third type of asymptote called a slant asymptote. In a slant asymptote, a slanted line is just a diagonal line. And a slant asymptote happens when the degree of the numerator is, when the degree of the numerator is exactly 1 degree more than the degree of the denominator. And in order to get the equation of the slant asymptote, when you identify that the degree of the numerator is exactly 1 more than the degree of the denominator, like an x cubed over an x squared, then to get the equation of it, so to get its equation, you do long division of the numerator over the denominator, and then once you're done with the long division, if there's any remainder left, you ignore it. Pretend it's not there. So that's what a slant asymptote. That's how you get a slant asymptote. And let's do an example of a rational function that has a slant asymptote. Let's do f of x is equal to x squared minus 3x minus 4 over x plus 2. So when you set up the domain, you see that it's all real numbers except for -2. If you want to factor this numerator out, you can factor it into x minus 4 times x plus 1. And there's no common factors, so there's no hole in this graph. You can set up the vertical asymptote as x equals -2. There is no horizontal asymptote because if the degree of the numerator is greater than the degree of the denominator, then there is no HA. But there is a slant asymptote I'll call it an SA for slant asymptote because the degree of the numerator is 2, the degree of the denominator is 1. So now we're going to get the equation of the slant asymptote. Well, lucky for us, we have a function that we can use synthetic division with. So if we do synthetic division, -2 on the outside and 1, -3, -4 on the inside, we get y equals x plus 5. Or I'm sorry, x minus 5 with the remainder of 6. And this remainder of 6 you just ignore because it doesn't really matter about the remainder. So we have an equation of the slant asymptote. Now let's get the x and y intercept. So the x-intercept is when the numerator is equal to 0, so that's 4, 0, and -1, 0, 2 x-intercepts. The y-intercept, when you let x equal 0, is -4 over 2, 0, -2. And now we have enough information to start sketching our graph. And if you'd like to pause it for a minute and try to sketch that on your own, that would be great. Otherwise, you can just go ahead and watch me do it. So let me go back. The vertical asymptote is x equals -2. The slant asymptote was y equals x minus 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here's a slant. Now this is just a slanted line, just like all the other asymptotes, just use a dotted line. So this is y equals x minus 5. And let's look at the x-intercepts are 4 and -1. And the y-intercept is -2. Okay, so now we can set up an xy table to get a few additional points. And it looks like we might want to get, let's see, x equals -3. And when x equals -3, if you plug that into the original function, looks like y equals -14, so we have to come way down here. And I'll continue the slant asymptote. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. -3, -14 is about right there. Let's get x equals -5. If we plug in -5 into the original function, looks like y equals -12. 1, 2, 3, 4, 5. So it kind of comes up like this. And let's get x equals -6. I'm just getting some additional points just to see what this graph is going to look like a little bit better. So -12.5. So it looks like it's going to come down like this. And so this function will come up and it'll go down, getting close to the vertical asymptote at x equals -2, and the slant asymptote is going to get closer and closer to the slant asymptote as it goes out. And over here on the right hand side, we've already gotten a couple points. Looks like this function is going to go down like this and come across. It's going to go through the y-intercept, the 2 x-intercepts. It's going to go up forever, and it's going to get closer and closer to that slant asymptote. So what you're going to find is, for the most part, if you have a rational function that has a vertical and a slant, the graph is going to be kind of this U-shaped figure in opposite quadrants. It's either going to be in these two quadrants and be kind of a thin graph, or it might be in these two quadrants, the southeast and the northwest, and be rather large functions. So on your worksheet packet that I gave you yesterday, there are some examples 5 through 8 that have slant asymptotes, and we'll get started on those tomorrow.